Hello, I'm basically at the Poincare Museum, which is in the Sorbonne University, and it's a maths museum. So I am now going to go in and have a little look at what we see in here. So I have to walk along here and go, it's right next to Madame Curie. So the question you may be asking yourself is, what did Poincare do? And the answer is, he made a conjecture which is about whether all shapes that are 3D have the same properties of a sphere. And the idea is that if you put a rubber band around a sphere, it naturally will come off and go to a, one point. But if you put it around other things that are 3D, like a donut or a torus, it won't do that. And so that's the basic idea. Now I'm going to go back to this and walk on in and see what it's like. So the first thing we get to look at is how different bits of maths interact with each other. They do not look well. And this is from arithmetic through to geometry, through to all the other sections there. So have a little look at that. What's marvellous is they look at lots of different problems along here and then relate them all to how we use everything from topology to algebra. And here we find out about the different
parler de singularité illusoire
in the building, and this is an old physical chemistry laboratory. We're right next to Curie's lab. I am now, now in an area which is the old lecture hall, and here we have everything explained to us, but mostly in French. That's the first woman to have won the medal for maths. There's Turing over there. But this is where they give lectures, but it's a historic area. And they talk about Gauss, and they talk about Wood and Bernoulli. The only problem is that most of the stuff is in French, which makes it a little bit less accessible. We are now downstairs, and this is fascinating because the entire area around here is all looking at Poincaré's conjecture about spheres. So it's actually looking at using cubes, and then there's a 64 small cubes, each with 3 colours, and they're trying to work out how you cannot use the same colour in each row. And so these are just fabulous ways of explaining maths problems, and these young men have obviously done very well with it. You can look at that there. So they actually illustrate the problems rather beautifully in here. This is really special, and here you can find out about things that were written 1550 BC, so from Egyptian times, and then if we go back we can see more about things that are going on, and we can look at stuff that came out with the invention of pi, for instance, or the discovery of pi, and find out more about it and where we first see it, and go all the way to the end. It's really, really cool, and it's basically about knowledge circulation and how it works. These are the different kinds of knots that you can do, and I really don't understand them, so I will be looking into this when I get home. but Collier is a chap that came up with the last one, which is I think 11 different types of overlap. I really like the one in the middle in the red and blue and yellow. And at the top we have just an ordinary red necklace that is not knotted at all. And each of them is represented by a polynomial. One just going to understand it a little bit more.